This lesson is the follow-up to the previous lesson I produced on how to interpret infrared spectra using a datasheet, and then we went through a brief example of how to read the spectra for it was an ester. This lesson has got another example to go through today, but before we get into that, let's just quickly recap what we learned last lesson. So if you remember, I said you can basically identify the spectra before you've even read the question and know the answer to the question, or at least part of the question, just by the shape, the distinct shape of the spectra. So what I have in front of us is 1, 2, 3, 4 different spectra. So this one, this double dip, really distinct double dip, I said this is always going to be an alcohol. A dead giveaway that there's an alcohol OH functional group present in the molecule. Next one, what does this look like? What shape is it? I said it's described as an inverted mountain. When you see that, it is always a carboxylic acid. So imagine now you're faced with a question, you turn your A-level paper, you turn your advanced placement paper, and then you haven't even read the first line, and already you know the answer. It's just great when you can recognize the shapes straight off the bat so that you can settle your nerves and then know you're working to an answer, or at least part of the molecule having this functional group. And then these are two really good examples of when you could be deciding whether it's an aldehyde or a ketone, or perhaps something else. So this one, we got a really, really strong peak there, 1650 to around 1750. So that means it has to be the C double bond O. And then we've got sort of a murmur there between 2000, around about 2850 to 3100. And it's not a very long extended peak. It's quite short. So then if you look at the data table, around 3100, sort of 2850 to 3100 is indicative of a CH bond. So this could actually be CH part of an alkyl chain, or it could be an aldehyde, because an aldehyde has a C double bond O with a H there. Although I mentioned previously that when it's an aldehyde, you tend to see the peak extended quite further down. But we know it's probably going to be an aldehyde or ketone because of the presence of this and the fact there is something there in that range, 2850 to 3100, which is the CH stretching range. Right, now let's look at the one above. What do we look at? Well, there's this obvious one. We can see that there is, again, there's 2850, or around about 2800, going up to pretty much the same number, 3100. But this is stretched all the way down. It's very distinct. It's very present. But we need a little bit more information. So we just put could be a CH at this point. But we need more information. So if we look to the right-hand side, have we got anything to work with on the right-hand side? You can see that's about 1100 to 123 again. It's coming in around just over 1300. Okay, so if you look at that range, we can see the possibilities there is that could be a C single bond O. Quoted in the data table is 1000 to 1300. However, we know there's no alcohol group there and there's no carboxylic acid group there. So it's not going to be an alcohol. It's not going to be a carboxylic acid. Then if we turn our attention to, well, if it isn't an alcohol, it isn't a carboxylic acid, maybe it could be an ester. But what an ester, aldehyde, ketone, carboxylic acid have is a peak at 1650 to 1750, indicating the C double bond O. And if we go to that number, so there's 15, there's 1650, there's 17, so there should be something there. That C double bond O peak is simply not there. So we know that it's not an ester, a carboxylic acid, an aldehyde, or a ketone. It cannot be any of those things. And it's not an alcohol either, because it hasn't got that double dip. We have to question whether that is actually a CO. So now let's go back to this number, so 2850 to 3100, and we've ruled out 1, 2, 3, 4, 5 different functional groups there. If you're thinking, well, there's not much left, what could this be? If we look at the 300 range, the 2850 to 300 is just a CH carbon chain. It could be just a CH carbon chain, but there's another peak to consider, which is this one. And if we dot this one down, that finishes at about 1500. And then it begins to grow again around about 1300. So that's 1300 to 1500. So if we check our data table, and we can see that the only thing that sort of fit in that range, it could be an alkene. Also, we have a CH bond there that's very strong. So this could be an alkene with a CH attached to the C double bond, as you would see in like ethene or propene. So that would be what we could go with the spectra in the absence of other information. Remember, guys, you will be given extra information as well. So don't worry, in a full-blown question, there will be extra clues. So to summarize, we've got this sort of peak comes up for an aldehyde or ketone. This one, certainly this was a little bit harder. That middle one is probably going to be an alkene, given away by the double bond and the CH, distinct CH stretch there. And then the top two, these are by far the easiest. The alcohol is the double dip, and then the carboxylic acid is the inverted mountain. An organic compound has the empirical formula C2H4O. The diagram shows the infrared spectrum of the compound. Remember what I said about not even having to read the question and knowing the answer before you've even started. Why? Because we got the shapes in front of us that give away the molecule. Immediately we have the double dip. So I know for a fact this has to have an alcohol. It must be the OH stretch. So this bit is the OH in an alcohol. And then I can see that's a C double bond O. So I've got to find something with an alcohol group and a C double bond O. So let's look at our options. So A is actually an aldehyde. So CH3, C double bond O, H. So I know for a fact it is not A. The next one, CO2H, that notation there is of a carboxylic acid. That's the way it's written. So it's not a carboxylic acid. Then we've got this one, HCO2C3H7. So what would that look like? Well, a hydrogen, then that would be bonded to a carbon, and there's two oxygens. So the only way that's going to work is a C double bond O and an O, C3H7. So that's an ester. Well, it's definitely not an ester because it hasn't got an alcohol group. So that's out, which means by process of elimination, it must be that one. But let's just draw it to confirm our answer. We've got CH3, then we've got C double bond O, then we've got CH, which is that H there, is that one there. And I can see attached to that is the OH, and then on the end is a CH3. So it's actually a hydroxy ketone, or a ketone with an alcohol group, which this spectra confirms.